everyone, and thank you so much for joining us here at the first ever Kubernetes Day in India. As Dan said, I work for Aqua Security, and we help enterprises. We have a product that helps enterprises secure their container deployments. We quite recently opened an office here in India, actually in Hyderabad. That's just part, I think, of a growing community of cloud-native people, and it's very exciting to see so many of you here today, spending your time to come and learn about Kubernetes and cloud native. So thank you and welcome to today. Right, so today I'm going to talk a bit about permissions, and I want to start by introducing this woman. I don't know, who recognizes who that is? Anybody? Shout out if you know. Grace Hopper. It is indeed Grace Hopper. So she was really one of the founding figures of modern computing. She came up with the idea of programming languages. So basically none of us would be here today if it wasn't for Grace Hopper. And she said a lot of really smart things. There was a quote that I only recently learned was one of Grace's quotes, and I don't know if you've heard this before, this idea that it's often easier to ask for forgiveness than it is to ask for permission. I'm going to go a little bit off-piste here and go a little bit personal. Grace Hopper is obviously a huge inspiration to all of us who do anything in the world of computing. I quite recently lost my mum. She wasn't in technology, she was a doctor, she was a psychiatrist. She was pretty much the top of her field, and she got there by working really, really, really hard. She also loved travel, and she loved the fact that she loved learning. And I think she would be hugely, hugely proud of the fact that I'm here today, in India, talking about something that I love and hopefully teaching you something. With a picture of Grace Hopper, who I think is an inspiration to all of us. Could I get a giant round of applause for inspirational women? Thank you. Okay. So I'm going to talk about permissions, and what I thought I'd do today is compare how we consider permissions in Linux and in Kubernetes. So who's heard the idea that Kubernetes is a distributed operating system? You heard that idea? A few hands going up that I can see. It's quite hard to see. So I think it's interesting to draw parallels between an operating system that we're maybe quite familiar with, like Linux, and how we do the same things in Kubernetes, if we think of that as a distributed operating system. So let's have a quick review of how permissions work in Linux. I'm sure most of you here are familiar with running ls-l, and you can see information about a file. It shows us who the owner of that file is and the group, and some permissions information about the file. Those permissions show us attributes for the owner, for the group, and for everybody else. And it tells us whether those different groups of people can read, write, or execute that file. So we have three actions that we can perform, three verbs that we can do with this file. And the permissions, well, there's a set of permissions for each of these, the owner, the group, and everybody else. So as an example here, the read bit is set in all three places, so anybody can read my app. Only the user Liz is able to write it, because the write bit isn't set for the other two sets of permissions. And anybody in the group staff, as well as the owner, could execute this file. But if you're not a member of staff, you can't execute my app. So all the information about who can execute or who can read or who can write the file is here. It's available in this output from ls-l. It's all attributes of the file, all encapsulated in that file object. So what's the equivalent of that in Kubernetes? We need to know, what's the equivalent of a file, what's the equivalent of the owner, and what's the equivalent of the permissions. So in Linux, basically everything is a file. There are also processes, but basically everything is a file. In Kubernetes, we don't really have files, but what we have is resources. We have lots and lots of different types of resources. We have pods and nodes and pod security policies and daemon sets. We have custom resources. Everything can be defined as a resource, and if in Linux everything is a file, and in Kubernetes everything is a resource, I'm just going to fill in this line and say the equivalent of a file is a resource. It's quite abstract. Let's have a concrete example of that. If I want to run an application called My App on Linux, it's a file that I can execute. If I want to run that same application in Kubernetes, we have to create a pod that will run that application. So I'm kind of saying that executing a file in Linux has the equivalent of creating a pod in Kubernetes. But what about the owner and the permissions? Kubernetes resources don't actually have owners or permissions. So how can, does that mean my equivalences here breaks down? Does this table make no sense? In order to find what the equivalents are, we need to look at role-based access control. And the clue here is in that first word, role. If we look at a definition of a role, here's some YAML, we can see that the role defines some verbs and some resources. So these rules are telling us what actions you can perform on what things. That's actually kind of similar to what we could see in Linux, where we had some verbs and a thing. There's only one specific thing in Linux, where in Kubernetes roles we're talking about probably a group of things, set of resources. We have a lot more verbs in Kubernetes. We have read-only verbs like get and list and watch. We have verbs that change state, so things like creating or updating a resource. And we have a few slightly more esoteric verbs, like you can use a pod security policy. So there's a bit more complexity, but it's still actions that we're performing on things. We might have a role that talks about the actions you can take on a whole group of things, a whole set of resources, like all the pods in a namespace. Or we might define a role that specifies a particular resource by name. The thing is, if I just go back to that for a second, there's nothing in here that talks about who can do this. It's only talking about the actions in the verbs and the resources, the things that you can apply those actions to. No information about who can do that. So we need to talk about the access part of this. Who has access to these roles? We have a role, and if we want to assign that role to a user, we create a role binding. And the role binding refers to the role, and it refers to some subject, a user. Or maybe it's a group. Just to make things kind of a little bit more weird, users and groups aren't actually a thing in Kubernetes. They have to be defined somewhere else. So you can refer to these users, but you couldn't do something like kube control get users. That's not a thing. But we do have some identities in Kubernetes. We have service accounts. So for users and groups, we're expecting those to be defined somewhere outside of Kubernetes. Maybe there's an LDAP directory. Service accounts are the identities of pieces of software that are running inside the cluster. And we'll see a bit more about that later. I mentioned briefly that the roles apply to a particular namespace. We also have cluster-wide equivalents, so there are cluster roles and cluster role bindings. Apart from the fact that they're applying across the whole cluster, it's kind of the same thing. So if we go back to a role and a role binding, we might want to also draw into this picture the resources that the role refers to. Maybe it's one pod, for example, or maybe it's a whole group of pods, all the pods in the namespace. And with all these things, that diagram kind of shows us what we need in place to express permissions in Kubernetes. We need all of these things, which contrasts quite starkly with what we needed for Linux, right? This is really simple. This looks quite a lot more complicated. So if you've ever found RBAC kind of confusing, this is why. It's got all these extra abstractions between the thing that you're going to apply the permissions to and the identities that you're going to give those permissions to. And with extra complexity, we get entropy. So if you remember your physics classes in school, you might recall the second law of thermodynamics, which says that systems will tend towards thermodynamic equilibrium. Thermodynamic equilibrium is kind of the most randomly distributed state that a system could achieve. Systems will tend towards more and more entropy, more and more kind of randomness, more messiness, less tidiness over time. So that's the second law of thermodynamics. The second law of RBAC is that entropy of permissions increases with time. Let me show you what I mean. We already start off, when you install Kubernetes, you're going to start with a whole load of service accounts and cluster roles and cluster role bindings. You know, I mentioned that service accounts are the identities that components or software running in your cluster, they run under these service account identities. And there's a whole set of them, this is just an extract, that are installed right from the get-go. These are really great. They give granular access, so all of the Kubernetes components only get the permissions they need to do their job. It's really great. But it's quite a, it's a lot to get your head around when you first install Kubernetes. You've got all these roles and role bindings already in place, and you probably couldn't hold that in your head if you tried. And then that's before you've started to give roles and role bindings to people in your organization. There's probably some people who need to be able to create pods, and maybe there are some other people who need to be able to perform all sorts of actions related to services. And then you might have admins who need lots of permissions to do lots of things across the whole cluster. So there's quite a lot of things that you would want to configure to get your roles and role bindings in place. And it's quite tempting to scope some of those things quite broadly. For example, you might say, well, everybody needs to create pods, or everybody needs to be able to read pods. So maybe you create some role bindings that have a really wide scope, like everyone, because it's human nature and it's easy. And then maybe somebody comes to you and they say, well, you've given me access to read pods. I can get them and list them and I can watch them, but I actually need to be able to update them as well. You go, okay, so I add update, give you a role that has update permissions. And then they come back to you the following week and they say, I need to be able to delete them as well. And in the end, you just think, oh, it'd just be easier to let you do everything. And you create some YAML like this with a wildcard that says, yeah, just perform any verb you like. And you could even be wildcarding the resources as well. And then that's thermodynamic equilibrium for permissions, allowing everybody access to everything. These permissions are additive. If there's any role out there bound to a user that gives a permission, that user has that permission. There's no blacklisting or anything. So the more of these things, over time, you're more likely to have more people, more groups, more service accounts that have permissions to do more things, just because it's human nature. And the problem with this is that the more people who can do more things, the greater the chance that one of those people behaves badly. They might be a bad actor, they might just be incompetent, and they might just, you don't want to give too many people the ability to delete all the resources in your cluster, because somebody will do that accidentally, and that will be a bad day. Further, you have your application code running in your cluster. And application code is software, so it's associated with a service account. And by default, the token that identifies that service account is actually accessible to the application. So the application could use that token to make requests of the API server, and we'll see an example of this in a moment. The problem is, if you have some vulnerability in your application, and maybe an attacker gets into your application, they can get hold of this token, and then they could use that to make requests of your API server. So by default, they're not going to have very many permissions, and they probably can't do anything too dangerous. But if you've granted that service account some extra permissions, that could be abused. So I have an example where I created a service account that I called Superpower, and a cluster role binding called Superbinding. This gives this service account full cluster admin privileges. And then I'm running a pod under that Superpower service account. So this pod has access to everything in the API. So if we could run the video, and hopefully this will be visible when we get the video. Okay, so I'm going to start by listing some pods, or seeing whether I can list pods with the Superpower service account, and it said yes, but with the default service account, I couldn't list pods. Oh, we've got audio. We don't need audio. You can just hear my typing. So I exec into that running pod, and I've just got a bash shell. And the first thing I'm doing here is setting an environment variable to the token. I'm storing the service account token in this environment variable. I'm not going to use that for a moment. I'm going to try hitting the Kubernetes API. And I'm just doing this anonymously. I'm not using the token yet. And we'll see, yeah, anonymous was forbidden access. So that's good. And then the next thing I'm going to try is actually the API for listing pods. We'll see whether or not I can do that. I'm still anonymous. I haven't expressed any sort of identity in this curl request. And again, I get the error code. I'm forbidden from accessing listing pods. I'm going to run the same query, but this time I'm using that service account token. So I'm passing in a header to authorize myself with this token. This is telling the API server that I am this service account, so I get all the permissions associated with that service account. And now I can get all the information I want about pods. I didn't do it, but because I had that cluster admin privileges, I could have deleted the whole cluster if I wanted to from inside the pod, and that would be bad. Okay, I think we need some power on this laptop. And I think we need to, okay. So that demonstration was really to show you that even if you trust everybody in your organization, you should be careful about the service accounts and the permissions that you give to those service accounts, because somebody might be able to abuse them if they manage to compromise one of your applications. As an administrator, how can you check whether you've reached this kind of maximum entropy? How can you check who has permission to do what? Can can individuals perform actions on a given resources? Who can delete pods, for example, or who can create pods? In Linux, we can do this really easily. We can just look at this file. We can easily see, just in this one snapshot, we can see who can execute the file. And if I'm the user Liz or a member of staff, I can execute it. And I can run a simple ID command and find out that, yeah, I am Liz and I am a member of staff, so I can execute that file. In Kubernetes, if I want to find out, can I create a pod, it involves quite a lot of steps. We have to start with the user. We need to find all the role bindings that reference that user. And then we need to find all the roles that those role bindings refer to. And if any of those roles let you create a pod, then that user can create a pod. So you have to kind of traverse these different abstractions to get that information. There is a tool, and we actually saw it in the beginning of that video, kube-control auth can I, as a user, perform a verb on a resource. So can I create pods as Liz? In this example, no. But if I wanted to list pods, yes. So we get this simple output telling us whether this identity can do a particular action on particular resources. What if we wanted to find out all of the identities who can create pods, for example? Again, we have to traverse all these different abstractions, but we have to kind of start from the other end. We have to find all the roles that allow the creation of pods. We need to find all the role bindings that refer to those roles. And then we need to find all the identities, the users, the groups, and the service accounts that are referenced by those role bindings. And I couldn't find a tool. There may be other tools out there, but I couldn't find one that made that easy. So I built a really early proof of concept that is on GitHub. So if you go to the GitHub Aqua Security page, you'll find kube-control who can, which is a proof of concept of doing that traversal. So if we play the next video, see a little demonstration of that. And it's asking who can list pods. And we get a whole list of basically related to the cluster RoleBindings and the RoleBindings, which service accounts and users and groups have that capability. And if I go back to the slides, it's giving output a bit like this. So we can see the type of subject and whether they're a service account, a user, or a group, and who they are. So tools like that could make it a lot easier for us to get the configuration of permissions right. So we've seen how Kubernetes permissions are quite a lot more complex than Linux. There kind of is some equivalence. We can draw parallels. Where in Linux we just have files, in Kubernetes we have more complexity, we have lots of resources. We have a lot more verbs, a lot more actions that we can perform on those resources. And we have these additional abstractions of roles and role bindings that are hugely powerful, but also can create some additional work in terms of figuring out who has which permissions and managing those, the configuration of these permissions. We also have the unusual idea of having users and service accounts as well as groups, but users and groups being managed externally to Kubernetes. So that's another source of potential confusion. But in broad strokes, that shows us how Linux permissions map to the Kubernetes permissions. And it's not really a surprise that it's more complex in Kubernetes because it's distributed, and distributed systems are more complex than sort of local systems. That's kind of just scratched the surface of RBAC. I co-wrote this book with Michael Hausenblas, which talks about lots of different aspects of Kubernetes security. There is more on RBAC and some of the tools you can use to manage RBAC, and and some other security information as well. This book you can download from the Aqua website for the mere price of your contact details. And do go and check out that proof of concept for Kube Control Who Can, and let me have your feedback. I'd love that. Coming back to that original quote, I think for Kubernetes we can just slightly rephrase that. Although configuring permissions is kind of complex and does require some tooling, and hopefully as a community over time we will make it easier to configure these permissions. But it's a worthwhile thing to do, because if you can get your permissions configuration right, you won't be having to go to your boss asking for forgiveness when somebody deletes important resources from your nodes. Okay. So I hope that's given you some clarity and some additional ways of thinking about permissions and access control in Kubernetes. Thank you.